Thank you all very much. Thanks. It's wonderful to be back here. I love Atlanta, and of course I love the History Center. I think I've been here about 20 times, and I do think Einstein gets a slightly bigger crowd than Ben Franklin or me trying to talk about CNN. And I'm really glad that you do have the world of Benjamin Franklin coming, I think, right after this wonderful Martin Luther King exhibit. And someday, after the world of Benjamin Franklin, maybe you can have the universe of Albert Einstein as a great exhibit. I wanted to do Albert Einstein. The last time I talked to you, it was about Franklin. It was about his form of genius, his creativity, and the fact that he loved science. Back then, an educated person was supposed to have a good feel for science. We've lost that a little bit today because so many of us get intimidated by science. So my goal was to say we shouldn't be intimidated by science. It is just as creative as any of the other arts and wonders of this world. And I wanted to take the most creative person I had ever read about, having spent some time studying him when we were trying to decide who was going to be Person of the Century at Time magazine. I wanted to write about Albert Einstein so we could all re-engage, not just let the scientists have him, but all of us re-engage in the wonders of the universe. And the first thing I discovered was really good news for those of us who are parents, which is that Albert Einstein was no Einstein when he was a kid. He was very slow in learning how to talk. So slow that his parents consulted a doctor, and the family maid dubbed him Der Depperte, meaning the dopey one in the family. And he was also rebellious, the type of kid we would have put on Ritalin. He caused one headmaster to send him packing for being too impudent and impertinent, another teacher to amuse history by saying Einstein will never amount to much. But I do think it was that slow verbal learning ability and that rebelliousness that made him creative and imaginative. And that's what set him apart from the other scientists of the time who were just about as smart but nowhere near as imaginative. First of all, the slow verbal ability. It taught him two things. First of all, to think in pictures. He never really thought in words. He was always picturing things, doing what he called thought experiments. It's what you and I call daydreaming when we're not Einstein, but for him he gets to call them thought experiments, of imagining what things would be like in these visual experiments he did in his head. And secondly, the slow learning, he said, taught him to marvel at things the rest of us find mundane. He said, if I discovered relativity, it's because I was still puzzling about the notion of time after every other kid had just assumed that time marches along at its own merry pace. But I found the march of time to be puzzling. At one point, his father gives him a compass when he's sick in bed one day. And Einstein says he sat up for nights trembling as he watched the needle pointing north, trying to figure out what the unseen forces in the universe were that were always pushing that needle, and trying to visualize in his mind an invisible force field that would make that needle point north. Now, you and I can probably remember getting a compass when we were kids. It's like, hey, cool. And then you put it aside. It's kind of mundane. And you forget about it about 3 minutes later. But this is a guy for whom things that we would find mundane, he found mysterious and fascinating. Also, the rebelliousness helped quite a bit. He was somebody who was always questioning every premise, always questioning authority, always trying to think in an unconventional way. And what I'll try to show you is that all the great theories, and he came up with all the great theories of the 20th century, came not from mental processing power, but from amazing visual imagination and just questioning the most obvious authorities that everybody took for granted. The one thing that's not true about Einstein, unfortunately, is the myth that he flunked math as a kid. If you Google Einstein flunked math, you get about 66,000 websites that says, as everybody knows, Einstein flunked math as a kid. So maybe there's hope for me, or, et cetera, et cetera. He was actually very good in math, even though he was slow in his verbal and language skills. And the reason he was good in math is, once again, he could picture it. He didn't learn it by rote. He said, I hated the rote learning of math, but I could try to picture, because he understood that mathematical equations were simply the good Lord's brushstroke used to paint the marvels of the universe. I was talking to my 16-year-old daughter, Betsy. Some of you may know her. She was here in Atlanta with us. And she was doing math a few weeks ago, doing her algebra, and she got one of the problems wrong on her homework, and she was asking me about it. And I said, well, look at it. It's 2x plus y squared, and you've multiplied it by this, so it's got to go up even faster. It's got to swoop upward like that. And your answer doesn't. He says, what do you mean? And I said, well, an equation is just a description of something in reality. It's just, a painting of like a sentence that describes a real thing in the real world. And she said, our teachers don't teach us that. And I said, yeah, it's like if you're reading, she's reading the Odyssey. I said, when you see the phrase in the Odyssey, rosy-fingered dawn, you got to stop and you picture it. And you do that, right? So when you see a mathematical equation, you should stop and picture it. So they never teach us to picture these things. Well, Einstein, being somewhat smarter than my 16-year-old daughter, at least in math, when he was 16, was puzzling over a new set of equations that had just been produced by James Clerk Maxwell. Maxwell's Equations, they were called. Maxwell's Equations, if those of you remember your high school physics, are the equations that describe a light wave, or more specifically, an electromagnetic wave. And the set of equations, and they tell you how the wave works. And among other things, it says, and the wave will always travel because of these equations at a constant speed, 186,000 miles per second or so, the speed of light. Constant speed. So Einstein, at 16, being taught these equations in school, is trying to visualize Maxwell's equations. And he said he did a thought experiment as a 16-year-old. What would it be like as a kid to ride alongside a light beam? What would it be like if you could try to catch up with the light beam? If you traveled almost as fast as the light beam or caught up with it, would you catch up with the waves? Would they be stationary compared to you? He said, and Maxwell's equations didn't allow for that. And he said, I walked around for weeks on end by myself in terror. He said, and all sorts of anxieties with my palms sweating. And I remember thinking, gee, that's not what caused my palms to sweat at age 16. But that's why he's Einstein and I'm not. But remember this tale because it is the basic germ of the theory of relativity. Is a 16-year-old kid trying to picture what it would be like to catch up with the speed of light, to catch up with a light beam. Now, being the rebel that I said he was, like my good friend Dr. Benjamin Franklin, he runs away as a teenager, runs away from Germany, runs away from the rigid rote learning of the gymnasium in Munich, which he hated, runs away to Italy, which is much more free, where his father was doing some work temporarily, and then to Switzerland. And he applies to what is the second best college in Zurich, the Zurich Polytechnic, and he doesn't get in. Flunks his entrance exams, or at least the language parts. He does fine in math. But after a year, after working for his dad, building electrical generators, which helps him understand moving magnets and coils and electromagnetic fields, and once again allows him to picture the underlying reality of some theory, Faraday's theory of electric fields and stuff. He's seeing how it works with coils and magnets moving as you build a generator. He finally takes his entrance exam at the Zurich Polytech one more time, and he gets in. He does moderately well at the Zurich Polytech as a physics student. But, as I said, this guy's a nonconformist, a bit of a rebel, impudent, impertinent to authority. He is able to tick off all three major professors at the Zurich Polytech. Professor Heinrich Weber, the head of the physics department, doesn't even teach Maxwell's equations. It's kind of too newfangled for him. He's an old physics professor, not quite sure about these new things like electromagnetic waves. Einstein, in a fit of rebellion, starts calling him Herr Weber instead of Herr Professor, which, of course, Professor Weber considers an insult and shuts off Einstein. Pernay is the laboratory and experimental physics instructor. Einstein was never a good experimentalist. That's why he had to become a theorist. But he goes into Pernay's class at one point for the big lab, and he gets the instruction sheet in front of the 7 other students. Einstein crumples up his instruction sheet and contemptuously throws it away and does the experiment his own way and blows up the equipment, at which point Pernay puts him on academic probation. And Minkowski is the math professor. Einstein then did not quite understand, although he later would, that math is not just what you do after you've discovered theories to clean it up, but math actually helps you. It's a roadmap to creating new theories. So he doesn't even attend most of the math lectures. He depends on his friend Marcel Grossman to take notes for him so he can cut the math classes, causing Minkowski to go down in history by writing on his report that Albert Einstein is a lazy dog. Thus it was that when Albert Einstein graduated from the Zurich Polytechnic in 1900, he's the only member of the graduating class in physics or math who cannot get a job, who's not offered a job as an assistant professor, not offered a job as an associate, as a teaching fellow, or even as a doctoral fellow at the thing. He can't get any job anywhere, not just in Zurich, but any other of the colleges where he's trying to become an assistant professor. In fact, he applies to about 15 high schools and gymnasiums in Germany and Switzerland and doesn't get a job. One of them has an opening for a math teacher. He thinks he's going to get it. He sends in all of his stuff. He says, I'll also be willing to teach physics. He doesn't even make the final 3 in the cut to be a high school physics and math teacher. So he wanders around for 2 years, basically unemployed, trying to do a little tutoring, until Marcel Grossman, the good guy who took notes from him in math class, helps him, through his father, find a job as a third-class examiner in the Swiss Patent Office in Bern. A third-class examiner because Einstein had not been able to earn his doctorate. His dissertation had been rejected twice. And so he could only be a third-class examiner in the patent office. But lest we feel too sorry for him, I'm convinced, and I try to show it in the book, that it was actually good for him to be a patent examiner, as opposed to an acolyte in the university or somebody who was trying to follow the authority of some senior professor and understand the conventional wisdom in the academy. What he's doing in the patent office is what he liked to do, which is to do thought experiments about people's proposals. People would come up with ideas, and Einstein would try to picture the underlying theories to see if they made sense. He had a great boss named Haller who allowed him, even though Einstein worked 6 days a week, to work on the side a little bit on his own papers. And Haller taught him one thing, which is question every premise. Also important was the fact that Einstein's job was mainly examining patent applications for electrical devices. And most of the electrical devices then had to do with synchronizing clocks, because Switzerland had gone on to standard time zones recently. And the Swiss, being Swiss, were really obsessive about making sure the clocks were synchronized. So if it was 7 o'clock in Bern, it was 7 o'clock in Zurich. And the one thing, there were about I think 70 patents between applications between 1902 and 1905 for different ingenious devices that could synchronize the clocks of Switzerland. And they all had one thing in common, of course. They sent a signal between 2 clocks. And that signal had one thing in common, which is it traveled at the speed of light. It was either a radio signal or a telegraph signal or a light signal or electric signal or whatever it was. Some signal traveling at the speed of light was supposed to help synchronize the clocks. And there, right outside of the Swiss Patent Office in the Postal and Telegraph Building, where all these signals are going out, right outside of Einstein's office. Those of you who have been to Bern may know it, the most beautiful clock tower in all of Europe, an 11th century clock tower, standing there in Bern with all the sort of cuckoo clock stuff coming out every hour, and a big archway underneath it. And the trains would go underneath the great clock into the station with the synchronized clocks along the platform. So this is what's in this guy's mind while he's still trying to figure out what happens when you catch up with a light beam. Now, we're lucky because despite the fact we sometimes think of Einstein as this aloof loner, he was like a totally sociable guy, had all these friends, was kind of a ne'er-do-well, passionate. He has another friend, Conrad, and Conrad goes away the first week of May in 1905 to try to finish his dissertation, doesn't write Einstein. So we have this letter that's one of the coolest letters in the history of science. And it's from Einstein to Conrad Habecht. And it's a typical Einstein letter, because we think of Einstein as some grand old professor. It starts off, "You frozen whale, you canned piece of soul, you frozen piece of sperm, you haven't even sent me your dissertation, so I am writing you a letter of inconsequential babble. But if you'll send me your dissertation, I promise to send you 4 papers I've been working on in my spare time." It's only in the second paragraph that you realize, oh, this is not inconsequential babble, but probably the most interesting tidings in the history of science. He says, the first paper is a study of light and radiation, and it is indeed quite revolutionary. And yes, this was a paper that says light's not just a wave, but it's a particle, a quanta. It's a foundation of quantum theory. Einstein does in his spare time as a third-class patent examiner. He says the second paper determines the true sizes of atoms and molecules. Now, back then, atoms and molecules, most professors weren't even sure they really existed. But it's still the simplest of Einstein's papers, so it's his latest attempt at a doctoral dissertation. He sends him this one, showing the true size of atoms and molecules using the way sugar diffuses through water. The other, he says, explains Brownian motion, which was this great mystery at the time, why tiny little particles jiggle in water. He said it's because he did a statistical analysis. He says it's because the molecules are hitting it at all sides in this way. And then he says the fourth is only a rough draft at this point, but it involves a modification of the theory of space and time. You go, wow, that's not inconsequential. What he doesn't tell Conrad is that as soon as he finishes that fourth paper and mails it into some journal, a thought occurs to him, and he writes a 3-page addendum to it, which says, if that's true, what I said about space and time and moving bodies and light and particles, then there's a relationship between mass and energy that deals with the speed of light, and it can be done in this equation, E equals mc squared. Most famous equation in all of physics. So there he's done this, still as a third-class patent examiner. No professors noticed it, really. And the theory of relativity is the one that, of course, most jangles things right away, even though quantum theory is more revolutionary. And relativity is a simple concept. It starts with that light beam experiment. Relativity, the principle of relativity, is something Galileo knew. It's in the discourse on two-world systems, the ship sailing, and in the hold of the ship. You can do everything and not even know whether you're moving or not. The fish can swim and the butterflies can fly, and you can pour coffee. If it's a smoothly sailing ship with no windows, you don't know whether you're in motion or not. That all motion is relative. That two planes passing each other, everybody can say, one of them can say, well, I'm sort of at rest and that other plane's moving. You may think you're at rest and you see a plane above you and it's gliding along. For the person in the plane, all the laws of physics apply just the same to her in the plane as they do to you. And she can look down and say, I'm at rest and the earth is turning beneath me. In fact, we're moving right now at 36,000 miles per hour just around the sun. Everything in the universe is in motion, and all motion is just relative to each other. But that conflicts, as Einstein figured out at age 16, with the constancy of the velocity of light, Maxwell's equations. Because if the speed of light is constant, it would seem to conflict with the notion that all motion is relative, because you'd think, well, if you're moving towards a source of light, it'd be coming at you faster than if you're moving away. And if you were speeding along near the speed of light, it would seem the beam would go slower, so the laws would not apply the same. And this causes him great anxiety. And he says it's incompatible, these two principles, the constancy of the speed of light and the principle of relativity. And he says to his other friend, Michele Besso, a ne'er-do-well engineer who Einstein had helped get a job in the patent office. They walked to work every day. He says, I've given up on it. I can't figure it out. Then one day they're walking in May of 1905, right before this letter to Conrad Habich, and they're looking at the clocks of a distant town, and the train's moving, and Einstein says, I've got it, and goes home. Next morning, he explains it to Michele Besso. He says it all has to do with what do you mean by saying something is synchronized? What do you mean by saying it happens at the same time? It's all relative. And he explains it using a visual thought experiment. As I say, this is not a scientist crunching mathematical formulas or results. It's a guy visualizing things. He says, what do we mean as a patent examiner when we say something is synchronous, something is synchronized? It means you need an operational definition, especially if you're a patent examiner. And if you say that event there and a distant event happened at the exact same time, the only way to really truly define that is to say somebody standing halfway between the two events would see it at the same time. The light would travel from both events to a person right in the middle, and he'd say happened at the same time. That's our definition of synchronous. He says, now suppose there's a fast-moving train and lightning strikes both ends. He does this in the paper. It's a very visual paper. Lightning striking both ends of a fast-moving train, and there's a person halfway between them on the platform, standing there on the platform. And the light from both strikes reaches them at the same time. And he says, they're synchronous. They happened at the same time. But the woman on the train, who's right in the middle of the train, right when the lightning strikes, but she's dashing forward. So in the nanosecond, well, a fraction of a nanosecond, that it takes the light from both lightning strikes to get to the middle of the train, she's moved forward a little bit. She says, no, the one in front happened first. And Einstein says all that means is that what is synchronous is relative to your motion. If you're moving differently from somebody else, you'll have a different definition of what synchronous is, what happens at the same time. And by that, he says, and he just does it by saying, what do I mean when something happens in a duration of time? It means I'll look at my watch and the hand's at 7, and the train enters the station at the same time. So if you're moving, time is different than somebody standing in the platform. Somebody moving real fast, somebody stationary compared relative to that person, time will be slightly different. Now, by the way, I know that's not easy. I try to make it easier in the book. There are a few diagrams. It's not easy. Max Planck didn't figure it out. He was the smartest guy at the time up until then, and he'd been looking at this problem. Lorentz gets into all sorts of Lorentz's contractions and everything else, but doesn't figure it out. Poincaré almost figures it out, but still can't figure out that if you're in motion, different states of motion, you have a different definition of time. And even after Einstein writes it, they're still not quite sure. But it answers his thought experiment. If you're trying to catch up with a light beam, you can go as fast as you want. But no matter how fast you go, even as you approach the speed of light, the light beam still travels away from you at 186,000 miles per second, the speed of light. But time slows down. And it slows down as you approach the speed of light. It gets much slower. Anyway, it's a counterintuitive, odd theory. It turns out to be right, that time doesn't tick along the way Newton said it did, second by second, no matter who observes it. It's different depending on the motion of the person observing it. And most of the physicists in Europe couldn't quite figure it out, just like they're kind of acting the way you are, kind of nodding like, okay, I kind of sort of get it, but I don't get it. And there's not much response. He still doesn't get a job. Helping him check those papers, by the way, and do the math was a very interesting woman. A woman named Mileva Maric. Mileva Maric was a young girl physics student in Serbia who couldn't get into the all-male Zagreb Academy and couldn't study physics because way back then, women had trouble studying physics, unlike today at Harvard or places where, well, never mind. And so her father, who's an Army officer, forces them to let her study physics. She becomes a great physics student at the Zurich Academy, many other places, and finally becomes the only woman in, you guessed it, the Zurich Polytechnic in Einstein's class. And not surprisingly, she's a brooding, melancholy, bohemian, exotic person, physics student. He's a ne'er-do-well, happy-go-lucky, footloose, runaway Jewish kid from Munich, and they fall madly in love. So much so that they take a long hike for days around Lake Como as the snow is melting their first year, and she gets pregnant. They have an illegitimate daughter named Lazurl that they put up for adoption in Serbia. You have to read the book to try to figure out what happened to her. They can't get married for many reasons. Their parents, obviously, at both sides are upset about it, and he doesn't have a job. But finally, when he gets this job in the patent office, with only Conrad Habich and Grossman and Michele Besso as the witnesses, he gets married to Mileva Maric. And they have 2 boys, and she works with him, helping him with these 1905 papers. But it is a tempestuous relationship, as we find out, or I found out from the new letters that were finally unsealed last year. And after a while, they have really, really fallen apart. They're using the kids as pawns between them. She keeps moving out and stuff. Finally, they decide to get a divorce, but Einstein can't afford it. So he offers her a deal. He says, one of these days, one of those papers will win the Nobel Prize. If you give me a divorce, you get the money. And she calculates the odds. She's a good scientist. She talks to Fritz Haber, another scientist. And finally, she takes the bet. It's not until 1922 that the people in that audience from 1905 quit going like that and said, yeah, he might be right. And he gets the Nobel Prize. And she collects the money and buys 3 apartment buildings in Zurich. In the meantime, Einstein has gone off, finally gets a job as a professor, wanders around a bit, Prague, Zurich, and finally the capital of physics and science in Europe, the University of Berlin and the Prussian Academy. So in 1913, 1914, 1915, the marriage is dissolved. World War I is breaking out. He's trying to get back and forth to see the kids, but it's hard to cross the border during the war. He can't get food because there are long lines for food, and he's very sickly and trying to do his theories. He has a first cousin named Elsa nursing him to health, and he ends up falling in love with her and marrying her. And in the meantime, he's trying to do, during this period, what is the most elegant, beautiful, and amazing theory in all of the history of science, which is the general theory of relativity. It's called the general theory because the special theory applies to constant velocity motion. Einstein doesn't like things that only apply to special cases. He wants everything to be a general unified theory. He wants it to apply to accelerated motion as well. And secondly, there's a problem with the special theory of relativity, is that it conflicts with Newton's theory of gravity. Now, already Einstein had thrown out Newton's theory of absolute space, and he'd thrown out Newton's theory of absolute time, but there was still the theory of gravity. And Newton said that gravity is simply a force that acts between 2 large objects, or 2 objects, any size objects, at a distance, instantly, so that the sun has this mysterious force that acts on the Earth instantly. The Earth does it on the moon, and galaxies do it on each other and stuff. And the theory of relativity says nothing can travel faster than the speed of light, because time goes to 0 when you approach the speed of light. And even information can't travel faster than the speed of light. So that conflicts with Newton's theory of gravity. So Einstein, this is not another great experiment or some heavy-duty, nerdy mathematical thing. He does another visual thought experiments. And the first of these thought experiments is simply to imagine being in an enclosed chamber. Imagine being in an elevator, say, with no windows. Now, if that elevator is sitting on the surface of the Earth with no windows and you're standing in it, what do you feel? You feel your feet being pressed to the floor, like mine are. You take something out of your pocket and you drop it. It falls to the floor of the chamber at an accelerated rate. Now imagine you're in the same chamber, windowless, and you're deep in outer space where there's no gravity, but the chamber is accelerating upward, what do you feel? He's doing a thought experiment. Well, your feet are pressed to the floor. You take something out of your pocket and you drop it, it falls to the floor at an accelerated rate. And he calls it the principle of equivalence. Acceleration and gravity are equivalent. Every test you can do, you can't tell whether you're in an enclosed chamber accelerating in deep outer space or you're in an enclosed chamber in a gravitational field. The effects are equivalent. Once again, this is something every other physicist should have figured out if they had been visual and imaginative and rebellious enough to do the thought experiment. Galileo should have figured it out. Galileo's the one at the Leaning Tower of Pisa who first understands, as Newton puts in the Principia, that inertial mass is the same as gravitational mass. For those of you who've forgotten your high school physics, inertial mass is how much force you got to push on something to get it to accelerate. Gravitational mass determines how much it weighs in a gravitational field. They're always equivalent, but nobody knew why. And Einstein says it's because gravity and acceleration are equivalent. Everybody goes, whoa. And he says, and that means that all gravity is really a curving of space. Now, once again, that sounds complicated, but he does it visually. And this is my whole point. This is a rebel who thinks in pictures. He says, imagine a two-dimensional fabric. To make it easy for you, imagine it's a trampoline fabric, a trampoline in your backyard. And you roll a bowling ball onto it. What does the bowling ball do? It curves the fabric. It bends the fabric. It warps the fabric. And imagine you roll a bowling ball, heavy bowling ball on to the fabric of the trampoline, and then you throw some billiard balls after it, roll some billiard balls after it. What do? They roll and they start curving to the bowling ball. Why? Not because the bowling ball has some mysterious attraction, but because it's, curved the trampoline fabric, and they roll down towards the bowling ball. And so that's what happens in a two-dimensional thing. That's why the billiard balls get attracted to the bowling ball, because it's curved the fabric of the trampoline. Now, we can picture that. Even if you couldn't picture the train with the lightning strikes, you can picture the trampoline with the bowling ball, I'm sure. And if you're Einstein, you can actually picture the bowling ball warping not just a two-dimensional fabric, but all three dimensions of space. I know, that takes an Einstein. And what really takes an Einstein is he can imagine it warping the four dimensions of space-time, because what the theory of relativity says is that space and time are all part of the same fabric. So all it's saying in the general theory of relativity is that gravity is when objects warp the fabric of space-time, and the warping of the fabric of space-time tells objects how to move. Trust me, that caused Europe to scratch its head. They felt somewhat like you might feel about it. And worse yet, at this point, anti-Semitism is arising in Germany, and they label it Jewish physics, meaning it's theoretical. It's not Deutsch physics. It's not German physics. It's not grounded in reality. It's all theoretical. And a great anti-Semitism happens, and of course it jangles with the whole notion of relativism, which is quite different, but it's all sort of thrown into this mix of the nationalist sentiments in Germany and others, where art and music, and from Stravinsky and Schoenberg breaking the bounds, the classical bonds, to Picasso and Kandinsky painting as if space and time and the frame of references change, to Proust and Joyce being interpreters of Einstein, as they say, with relativism and stuff. If you read Paul Johnson's Modern Times, it starts with Einstein's general theory. It says it breaks the bonds of absolutism and jangles into this relativism that causes Europe great discomfort. Well, Einstein, among other things, becomes much more proud of his Jewish heritage the more he gets attacked for having produced Jewish science. But he also says, if you want to see if I'm right or not, I've come up with a test. He says, if gravity warps the fabric of space, it means that even a light beam will curve when it goes next to something big. That gravity will bend light. You can figure that out even from energy having an equivalence to mass. It means light beam gets bent. And he even does the calculations for everybody, saying the light from a star, starlight, as it passes right next to the sun, the gravitational field of the sun will bend the starlight by 1.7 arc seconds. Now, that's very difficult to look at because the sun's so bright. But right at the end of World War I, a British Quaker, very sympathetic to the Jewish causes, a pacifist British Quaker who had refused to serve in World War I, named Arthur Eddington, decides he's going to prove right the theory of a German Jew overthrowing the theory of Sir Isaac Newton. So he sets sail for an island off the coast of Africa named Principe, and another part of his team goes to Brazil for the solar eclipse of 1919. And in the solar eclipse of 1919, because it's a solar eclipse, you actually can see the stars light as it goes right by the sun. And they set up big photographic equipment to know where the stars should be and that sort of thing. And it takes them 4 months to get all the photographs back to London. At which point they call a great meeting in the hall of the Royal Academy on Piccadilly. There's a picture of Isaac Newton, the first president of the Royal Academy, there. Sir Arthur Eddington turns around and says, "Forgive us, Sir Isaac, your universe has been revised. Einstein is right. Gravity bends light." Einstein wasn't able to go to England for this. I mean, it was just, they weren't, right at the end of the war was just over and couldn't travel there. Telegram comes. He's with a graduate student. He shows it to her, saying that he had been proved right, and she's thrilled. She says, "You must be so excited." And he said, "No, I was confident." She said, "Yes," but she says, "Yes, what would you have felt, though, if it had turned out the other way?" And Einstein said, "I would have felt sorry for the good Lord because the theory is correct." This was in the days when the New York Times knew how to write great headlines. If you get the book, there's a chapter called Fame, and right at the beginning I have the headline the next day from the New York Times, written by their golf correspondent, Henry Crouch, who happened to be in England for a golf tournament because the science correspondent wasn't there. He goes to the Royal Academy, has to have Arthur Eddington explain it to him twice, but the headline of the New York Times the next day is, "Lights All Askew in the Heavens. Einstein's theory triumphs. Eclipse observations show that gravity bends light." And then the final headline was, "Stars not where they were calculated or were supposed to be." And then the final line is, "But nobody need worry." It's just this marvelous headline. And Einstein suddenly becomes a super celebrity. I mean, a celebrity the likes of which not only no physicist, but no touring rock band has ever had before. And it comes at a time when people are hungering for a new age, new heroes in a new age after World War I, especially a hero that transcends the politics of it all. And Einstein uses his celebrity when Chaim Weizmann asks him to join the Zionist cause, because he's so upset about the rising anti-Semitism that he agrees to go with Weizmann to America to raise money in 1921, right after the eclipse observations, for Hebrew University and for the refugees, Jewish refugees and scholars. So they sail to America, and America's never seen anything like this. More than 10,000 people are gathered that night at the Battery when the ship comes in. Weizmann comes off first, and the press asks Weizmann the question they ask everybody during those 4 or 5 weeks when he's touring around. They ask Weizmann, "Do you understand Einstein's theory of relativity?" And Weizmann says, "On the way over, Professor Einstein explained it to me many, many times, every night. And by the time we got here, I was convinced that he understood it." He travels all over the Midwest and stuff. Their parades, they shut down businesses. He tours up Fifth Avenue in an open car. Those of us from Washington, only us can fathom this, that when he comes to Washington, the U.S. Senate decides to debate whether or not relativity is correct, with Senator John Rankin of Mississippi in the opposition and Boyce Penrose of Missouri in the favor of it. He goes to the White House to meet President Harding. They ask President Harding, of course, "Do you understand relativity?" Back then, politicians had a modicum of honesty, so Harding says no. At which point, Einstein says that it's okay because Einstein says he doesn't understand the theory of normalcy, and that was Harding's political platform. Anyway, at that moment, too, something interesting is happening to Einstein. He wins the Nobel Prize, as I say. He doesn't win it for relativity. He wins it for an aspect of quantum theory, the photoelectric effect. And what's ironic is it's at this point, around the mid-1920s, when he's still making his last contributions to quantum theory, a few good contributions, but he's really starting to resist it. Quantum theory has evolved into a new form of mechanics, a quantum mechanics, that involves uncertainties and Heisenberg's uncertainty principle, that things sort of depend on your observations and that you can't, that things happen by chance, they're random events. Niels Bohr and others talk of, instead of certainties and causality or strict causality, they talk of probabilities. And it causes Einstein to say over and over again, I cannot believe that God would play dice with the universe. He believes in an underlying reality, and he's spun around from being a very rebellious young Turk to being somebody defending the classical order of strict causality and stuff. One point, Niels Bohr says to him, after he keeps saying, I can't believe God would play dice with the universe, Niels Bohr says, Einstein, please quit telling God what to do. Now, people thought sometimes when Einstein said all these things, that he was using God as a pure figure of speech. But around the same time he's becoming more classically deterministic and conservative in his science, he's becoming more insistent to people who are surprised to hear it, that he's religious, that he believes in God. He believes in an impersonal God, not a God who you can pray to intervene and change things. He said, for some people, miracles are evidence of God's existence. For me, it's the absence of miracles. The fact that the universe follows laws is evidence of God's existence. And at a dinner party in Berlin, he's 50 years old, and reflecting on this, writing about religion some, the hostess is surprised and asks him, I can't believe you really believe in God. This is the late 20s in Berlin, very secular period. He said, yeah, we're like a small child entering a library, and we dimly perceive that there's an author to some of these books, and that they've been ordered, and that they're ordered in a certain way, and we spend our lives marveling at these mysteries and trying to understand how the books were written and how they were ordered. And as we do that, we're awed and we're humbled by it. And that's a sense to me of a cosmic religion, and that's to me an intimation of God. He said, there's a spirit manifest in the laws of the universe, a spirit in the face of which we must be humbled. That to me is my cosmic religion. And of course, that totally baffled a lot of people. The cardinal in Boston at one point gave a sermon saying, despite what Einstein says, it still smacks of atheism. So Rabbi Goldstein, who was the leader of the Reform movement in New York, sends him a telegram saying, Einstein, do you or do you not believe in God? Answer 25 words or less, answer paid. And Einstein doesn't even use the 25 words. He says, I believe in Spinoza's God, a God whose spirit is manifest in the beauty of its laws. Anyway, this is, a sense of the things that were affecting him as he crouches down in some ways and defends the old scientific order. He also changes his pacifism. He had been very much of a pacifist. But as Hitler comes to power, he rejects his pacifism. Unlike some people in Washington, he believes that factual evidence should have some relation to your general theories and beliefs. So he changes his belief when the facts change. He writes a letter to Roosevelt saying, based on E = mc² and everything else, there could be nuclear chain reactions. You could build a bomb. He wants the bomb. He suggests that Roosevelt start a project because Germany might build a bomb. And Roosevelt reads the letter, says, we must act, and starts the Manhattan Project. Ironically, Einstein, because he had been a pacifist, J. Edgar Hoover had collected a dossier of 1,400 pages on him and decided he was a security risk, so he's not allowed to work or know about the Manhattan Project after he got it started. Einstein, for a while, fights against sort of the rising McCarthyism and stuff like that, becomes an American citizen. He says the thing that makes America great is the connection between its freedom and its creativity. Because people have free thought and free expression, they can be imaginative and creative. Americans will never give that up, and that's why we have to fight for free speech and free thought. He becomes a leader in the fight against McCarthyism. But mainly at the end of his life, he's still working on the two things that matter to him most. The cause of world peace, because after the bomb is dropped, he feels responsible and becomes a leading advocate of arms control, and also the unified field theory. His way of trying to find the grand theory that will incorporate quantum theory, relativity, electromagnetism, gravity, everything, so that things won't happen by chance, so we'll know the causal laws. And even on his deathbed in Princeton, he had had an aneurysm and it burst in his abdomen. He's there in the hospital knowing he's, never going to leave the hospital. But he brings his papers with him. He had been offered the presidency of Israel, which he smartly declined, but he agreed to give a speech for Israeli Independence Day, but he told Ben-Gurion that we would do it on one condition. He didn't want to talk just about Israel. He wanted to talk about the need for all of world peace. And so he writes the first sentence of that speech from the hospital bed. He writes, "I speak to you today not just as an American and not just as a Jew, but as a human being." And then the pain becomes really great, and he puts the papers aside. But a few minutes later, he takes back one more sheet of paper, which is a set of calculations. For the past 20 years, he had been working on it, never quite finishing it, the unified field theory he was trying to get. And you can see that last page of calculations, line after line, still making a few math mistakes, crossing it out, 4/8, then crossing it out and changing it. And one last line of equations that finally dribbles off as he goes to sleep for the very last time, trying hard to get one step closer for all of us to the spirit manifest in the laws of the universe. And so that's how a very impertinent and rebellious but extremely imaginative and creative third-class patent clerk became the mind reader of the creator of the cosmos and the locksmith of the mysteries of the atom and the universe. Thank you all very much. We have, 5 minutes, 10 minutes? Yeah. The microphone's there, and then I'll go sign books and explain relativity one more time if you want me to. Yes, sir.
I just got through reading a book on Einstein on race and racism.
Yeah, Fred Jerome's book. It's very good and interesting.
And I got the impression from his beginnings with Paul Robeson and the attempt to start the precursors of today's NAACP and other movements that later ended up in civil rights movements, that Einstein spent most of his last years on these efforts, or apparently his daytime efforts, actually intermingling with the poor kids of New Jersey and so on, and his nights with the unified field theory. Do you have any thoughts on that?
Well, I actually spent early mornings walking to the Institute and doing unified field theory with two mathematicians, and a lot of times in the afternoons he would meet either with people opposing McCarthyism or on the race issue. When Marian Anderson, the famous black contralto, I think she was, or whatever, singer, the one who couldn't sing at the DAR Hall in Washington, comes to Princeton to sing, she's not allowed to stay at the Nassau Inn because she's black. And Einstein, who doesn't drive, walks over from 112 Mercer Street to the Nassau Inn, introduces himself, and offers to have her stay at his house in his little guest room, which she does, and does every time she comes to Princeton thenceforth. Same with Paul Robeson and others. Einstein was very dedicated to the cause of racial justice in America, and it was obvious. I mean, it was not hard to explain. I mean, he had grown up as an outsider, as a Jew in Germany, and it just appalled him that people weren't treated equally. And so he speaks at Lincoln University at one point in Philadelphia. The only place I know of, he got about 100 honorary degrees. Where he actually went to go collect the degree, a black college there. Horace Bond was the president of Lincoln University. He had a kid who Einstein, really young kid, Einstein sort of met, shook hands with, and told him to keep studying. And y'all would know him because his son was Julian Bond. And so it's one of the many. I could speak for hours on Einstein. I'm glad you brought that up, but there's obviously a lot of this in the book, and it's a very inspiring part of Einstein's life. I hope I didn't intimidate people too much. Yeah.
Well, I'm going to come down because I'm not all where you were throughout that talk, but I'm curious about your journey as a historian, as a writer, and how you might be able to compare the Einstein project to Benjamin Franklin.
Mm-hmm. I have always been interested in how people's minds work as a biographer. I started with a friend of mine doing a book called The Wise Men. And by the way, you all are very successful, so you know that smart people are a dime a dozen. It takes something else to be a successful or significant person. And that's what I've always tried to explore, because I've seen a whole lot of smart people who couldn't really amount to much. But so I started with the wise men. And the wise men were not exactly the smartest people in the early Cold War period. John McCloy, Robert Lovett, and stuff. But they had a certain creativity and a certain wisdom to them. Their creativity meant when they were faced with a new global struggle, they created whole new ways of dealing with it in a common sense way. Like NATO, Mutual Defense Alliance, the threat of the spread of Soviet communism. The World Bank, IMF, the Marshall Plan. NSC, they had a doctrine, the Truman Doctrine, to explain what they were doing. NSC 68. And the reason I wrote that book is, I look now at our statesmen, especially now when we're faced with a new global challenge that's just as threatening in some ways as the threat of the expansion of Soviet communism. And we have leaders who are really, trying to stand up to it, but they're not being creative. They're not creating, they're trying to use the old institutions like NATO. They should have a new, if you'd had the wise men here today, they would be creating a new type of alliance to deal with terrorism and the rise of Islamic terrorists and fundamentalism, and new types of Marshall Plans and new doctrines instead of trying to rely on the old 1945 system that the wise men created. Sorry, that's a different speech. Then likewise, I wanted to look at Henry Kissinger, who was the smartest person you'll meet, but obviously his smartness didn't necessarily translate to pure greatness, and I wanted to know why. Was it intellectual honesty that he missed? Was it, an ability to be wise the way John McCloy and Robert Lovett were? So that was a look at somebody very smart, but who was lacking some of the trust in democracy, some of the humility that other people's opinions may be right, some of the wisdom, etc. Then with Benjamin Franklin, if you've read the book, he's not the smartest guy during the writing of the Declaration of the Constitution. You got Jeffersons and Madisons who are really sharp tacks. But Franklin is the sage. He's the wise person who understands how to find the common values that we can build on. And I wrote that book because I thought we were becoming a society in which we were far too polarized and everybody was ripping each other apart when we all basically share a set of common values, and that's what Benjamin Franklin did, was say, here's the common values we share, let's build on them. And then with Einstein, once again, a person who was smart, but I hope this lecture tried to show that I will say something that when you put it out on the web, somebody will be shooting me down on it, but I'm not sure he was smarter than Max Planck or Lorentz or Poincaré. Certainly wasn't as good of a mathematician as Poincaré or Hilbert or some others. But I was looking at what did Einstein have? Well, he had an imagination. He had a creativity, just what Mozart had. And there's a creativity that allows you to think visually and feel the harmony of the spheres. And when we deal with math and science today, as I said earlier, we kind of think, it's tough, I don't get it, and it's nerdy and it's rote, but we'll make some teacher cram it down the throat of our kids, instead of feeling that awe and the wonder that an Isaac Newton can feel watching an apple drop, or a Galileo can feel at the Leaning Tower of Pisa. Or an Einstein can feel trembling while he holds a compass, or thinking of what it's like to go beside a light beam, or being in a falling elevator or a rising elevator. And that sense of wonder, of creativity, that sense that, gee, this universe, we should be awed by it every single moment. That's what made Einstein great, and I think we could use some of that in our society today. Anyway, one more.
Certainly a great man with a great imagination, which your book describes very well. But given how many great people there were in the 20th century, I'd be interested in your perspective as to why time chose
Why did we
Albert
choose Einstein over the others? The others were basically Churchill, Roosevelt, Gandhi, Einstein, King, whatever. I sort of, because I was the editor that, I said, let's look not at who should be it, but what the most important themes of the century were. What was, we're going to remember, say, the 18th century for the great, statescraft that leads to everything from Adam Smith and the Wealth of Nations to Thomas Jefferson, Ben Franklin, and the Declaration. And we're going to remember the century before that for its science, for Newton and Galileo, and we'll remember the technology of Gutenberg or whatever. But what will the 20th century be remembered at? And there were three things that seemed to me the grand themes of the century. The first was the triumph of freedom over oppression. Basically, the triumph over Nazism and then over Soviet or communism or whatever. That there were oppressive political or control or authoritarian political regimes that gave way to regimes that were not as authoritarian and allowed more individual liberty. The second was sort of a civil rights type theme, where individuals came to their rights, whether it's women getting the right to vote, or blacks being enfranchised as citizens, or Gandhi taking India so that they were not colonies of Britain, but their own citizens. And you could look at Gandhi or Martin Luther King. The first example, you look at Churchill or Franklin Roosevelt. Second theme, you can look at a Gandhi or Martin Luther King. And then the third is probably the most amazing century of science and technology, in which the two great theories that are now the pillars of physics, relativity and quantum mechanics, in which we go to outer space for the first time, which we create transistors and microchips and television and new forms of tech, and in which that technology and that science actually enables the spread of freedom, because the individual empowerment that comes from the free flow of information from radio, from TV, from, for that matter now, the internet, from the microchip, gives an individual empowerment that I think changes the politics of things. And in the end, I felt, first of all, a century or two from now, it will be remembered as the most amazing century of science and technology, and that will be the foremost thing. You can argue that, but to me, that was it. Secondly, even if not, Einstein was an exemplar not just of the two great underlying scientific advances, the best since Newton, which is relativity and quantum theory, but also of every technology has Einstein's fingerprints on it. Microchips, photoelectric cells, lasers, nuclear power, atomic power, space travel, you name it. But also, he is the exemplar of a century in which was a century of refugees, huge flows of refugees that had one thing in common. They were fleeing oppression. They were fleeing authoritarian systems, whether it be Hitler or Stalin or whatever, and going to countries that offered more freedom. And those countries that offered more freedom ended up being more creative and more imaginative, and they triumphed. And that was sort of, Einstein was the embodiment of that. So that's why not only did we pick Einstein, but I decided that's going to be my next biography. Thank you all very much.